Okay, here's another simple problem which you might come across in an exam. This one involves a horizontal beam which is held to a wall by a tie, a cable tie ZW here. So the first thing you would do in an exam is sit down and have a look at this question and take in all the information that you can and pick out the key information. You can see immediately that this distance here from W to X is 0.4 meters. And this distance here from P to Y, which is the whole length of the beam, is 0.8 meters. So what you can immediately say from that is this point W here is directly in the center of the beam. So it's the center of mass of the beam because it's a uniform beam. Therefore, the weight force from the beam is going to act from this point. So the first thing you can do is draw some arrows representing the forces, and you can draw an arrow directly down there from W to show that the weight force exerted by the beam is acting from that point in a downwards direction. Now you want to draw in the other force which is acting on this beam, which in this case is the tension force. Tension force is tension in this tie ZW, and it's a force acting from W in this direction here. Normally we use T for tension, so you can draw that force on your diagram even with a T there. Probably best to do a new diagram in your working space so you can fit all the arrows in really well and you know exactly what's going on. So there are your two main forces, and the other bit of information you've got is that you've got 30-degree angle to the horizontal that the tie makes here. Now in this particular case, you know that the beam is still, therefore there are two conditions that beam must satisfy. One is that the sum of all forces must equal 0. And the second is that the sum of all rotational forces, or torques, must also equal 0 because the beam is not moving, it's not rotating. Okay, so by solving one of those two equations, you can solve this problem. Now in this particular case, it won't always be the case, but in this particular case, it's a fairly simple problem to solve because both forces are acting through the center of mass of this beam. So all that you need to do is resolve the vertical component of the tension in this string and set it equal to the weight force which is acting through W, and you can solve that to find T. So if you let T equal the tension here and mg, which you were given the mass of the beam, times gravity, which is 10, acting down this way, all you need to do is balance it in the force with the force which is acting vertically from W. Now the force which is acting vertically from W is a component of this tension force here. It's the vertical component which is acting in this direction. Now you can draw an arrow directly out from this point and call it the vertical component of T, or T vertical. And the magnitude of this force here must equal T cos 60, because if you look at this angle here, that angle there is 30 degrees, and then there must be another 60 degrees here in that angle to the vertical. Therefore, by resolving that force, cos 60 equals adjacent over hypotenuse, you can come up with the equation the vertical component of the tension equals T cos 60, which is acting from W vertically upwards. And once you've got those two forces, because they're acting from the same point, and there's no difference in the rotational torques around other points, you can immediately resolve those forces against each other because the sum of those forces is 0. So if the net force is 0, then T cos 60 equals mg. In this particular case, you were given the mass of the beam, and you know what gravity is, 10. So you can solve, and you know what cos 60 is because you can do it on your calculator. You can solve for T by substituting all those values into the equation and answer the question to work out the tension in the string or tie ZW. And that's how you solve that problem.